Good day, everyone. We are Group 5, and today we are excited to present the Hiele Model of geometry thought. This mathematical learning model focuses on how students understand and learn geometry, developed by Hiele and Hiele. The model breaks down the process of geometric thinking into distinct stages. By the end of our presentation, you will have clear understanding of how the Hiele model can be effectively applied in the classroom to enhance conceptual understanding, problem-solving abilities, and overall student engagement in learning geometry. The Hiele model is a model that explains how students learn geometry, focusing on the progression of geometric thinking. This model, developed by Dutch mathematics educators and researchers Herr von Hiele and his wife Nina van Hiele, outlines a hierarchical system of 5 levels of geometric thinking: visualization, analysis, abstraction, formal deduction, and rigor. First, level 0, visualization. At this level, students identify geometric figures and shapes based on their appearance. Next, level 1, analysis. At this level, students begin to recognize and describe geometric shapes by their properties. Next, level 2, abstraction. At this stage, students organize their knowledge of geometric properties and begin to understand how different properties are related. Level 3, deduction. At level 3, students are able to reason formally and understand the structure of axiomatic systems. They can distinguish between undefined terms, definitions, actions, and theorems and use this to construct formal proofs. Next, level 4, rigor. At this level, students are capable of reasoning about mathematical systems in a highly formal and rigorous manner. They can study geometry without relying on reference models or physical representations, and can manipulate geometric statements and theorems purely through logical reasoning. This model emphasizes that geometric thinking is not a linear process, but rather a progression of cognitive development that varies from student to student.
Now, we will focus on how the Hiele model can be effectively used in teaching and learning mathematics, specifically geometry. As we go through the 5 phases of the learning process, we will see how the teacher can guide students through each level of geometric thinking. The first phase is information or inquiry. For example, when introducing a rhombus, the teacher might say, "This is a rhombus. Now, try to construct some more rhombuses on your paper." This encourages students to visually engage with the concept, starting their process of recognition and exploration based on their prior knowledge. Next, we move to the guide or directed orientation phase. For example, the teacher might say, "What happens when you cut out and fold the rhombus along one diagonal? What about folding it along other diagonal?" This hands-on activity allows students to explore the properties of symmetry and diagonal relationships of the rhombus. Now, we move to the explanation or explication phase. For example, the teacher might say, "Here are the properties we have noticed, and now we will introduce the associated terminology. The diagonals lie in the lines of symmetry. There are 2 lines of symmetry, and the opposite angles are congruent. The diagonals bisect the vertex angles." By explaining these properties and terms, students can formalize their understanding of the rhombus, creating clearer, more structured view of the concept. Moving on, we have the 3 orientation phase. For example, the teacher might say, "How can you construct a rhombus if you are only given 2 of its sides?" This problem requires students to apply their knowledge of the rhombus properties in a new context, helping them to reinforce and extend their understanding. Finally, we come to the integration phase. This phase helps students solidify their understanding by reflecting on the key concepts and consolidating their learning. By following these 5 phases, teachers can ensure that students progress through the levels of geometric thinking in an effective way, developing both conceptual understanding and problem-solving abilities. So now, we will explore 3-dimensional shapes or solids like the cube, pyramid, and cone. We will guide students through a progressive understanding of these shapes, starting with recognizing them visually, exploring their properties, and moving on to applying geometric concepts in problem solving. Now let us begin by recognizing shapes. Here's a cube. At first, students will simply identify the cube based on its appearance. They will notice it has 6 faces and all the edges are the same length. At this stage, students are recognizing the cube as a solid with equal faces, but they haven't yet explored its deeper geometrical properties. They know it's a cube because of its visual symmetry and identical faces. Now let us look at a pyramid. This shape has a square base and 4 triangular faces that meet at the apex. Students can easily identify the pyramid visually, but their understanding will deepen as they explore its properties more closely. So now, let us explore the properties of the cube. It has 6 square faces and equal edges. The angles between the faces are all 90 degrees, meaning each face is a right angle. These are crucial properties that we need to understand. And for the pyramid, students begin to understand that the base is square and the 4 slanted faces meet at the apex. They can now describe the unique features of the pyramid compared to the cube, like the slant of the faces and the triangular surfaces.
Now, let's apply what we've learned with the problem-solving activity. Here's a cube with a side length of 4 cm. To find the volume, we use the formula volume is equals to side cube. Volume is equals to 4 cm times 4 cm times 4 cm is equals to 64 cm cube. So, the volume of this cube is 64 cm cube. We're applying the properties of the cube. It equals edges and faces to calculate the volume. Next, let's move on to a pyramid. We have a pyramid with a square base of 5 cm and a slant height of 8 cm. To find the surface area, we need to calculate the area of the base and the area of the slanted faces. Surface area is equals to base area plus 1/2 times perimeter of base times slant height. First, the base area is height times side. So, 5 cm times 5 cm is 25 cm cube. The perimeter of the base is 4 times 5 cm is 20 cm. Find the surface area of a pyramid with a square base of 5 cm and slant height of 8 cm. Surface area is equals to 25 cm squared plus 1/2 times 20 cm times 8 cm is equals to 25 cm cube plus 80 cm cube, and we got 105 cm cube. So, the surface area of the pyramid is 105 cm cube. As we move forward, let's take a more advanced problem. For example, if we have a pyramid with a triangular base, we can use the same principles for calculating surface area and the volume. But the calculations will differ due to the shape of the base. Students can now start applying the formulas they've learned to even more complex shapes, while understanding the connections between different types of solids. To summarize, today we explored 3D shapes, the cube and the pyramid. and how we can move from recognizing shapes visually to solving real-world problems involving volume and surface area. Thanks for joining us. We hope this demonstration helped you see how students can progressively develop their geometric thinking. Keep practicing and we'll dive deeper into more geometry topics in future lessons.
As we have learned earlier, the Van Hiele model plays a crucial role in helping students develop their geometric thinking. It provides a step-by-step framework, allowing students to gradually progress from recognizing simple shapes to solving complex geometric problems. Let's dive deeper into how this model enhances mathematics learning, particularly in geometry. First, the Van Hiele model strengthens conceptual understanding. Next, the Van Hiele model improves problem-solving skills. Another key benefit of the Van Hiele model is that it engages students. Finally, the Van Hiele model helps reduce errors in learning. Van Hiele model enhances mathematics learning by fostering conceptual understanding, strengthening problem-solving skills, boosting student engagement, and minimizing errors. This approach helps students not only understand geometry, but also develop the confidence to tackle more advanced topics.
Overall, the Van Hiele model is a powerful framework that helps teachers structure their lessons in a way that aligns with the cognitive development of their students. By using the Van Hiele model, we empower students to approach